All right, so we talked about transforming a system of equations into a augmented matrix, and now we're going to use that in order to do Gaussian elimination. So let's talk briefly about what the process of Gaussian elimination is. One, there are three allowed moves. There's three allowed moves. One, we could switch rows. And that's called permutation. We're going to write that as P. And then we're going to define whichever rows they are, P A to B. So if we switch rows 1 and 2, it'll be P1, 2. All right? 1 becomes 2, 2 becomes 1. 2, we're going to have, we're going to multiply a row by a scalar. And we'll say, okay, so multiply, and that'll define the row. This is the row that we're going to be multiplying. And then we're going to have this, whatever the value is for the scalar, call it S, inside of parentheses. Then, 3, we're going to have addition. It's actually addition with scalar multiplication. And so what that's going to look like is we're going to say, okay, we can add A to B, and we will multiply the first one by some scalar, so let's call that scalar S. So we'll define this notation a little bit better in just a couple of minutes. But what we're basically going to be doing is we're going to be using any one of these three allowed moves: addition, multiplication, or switching of rows, permutation. Basically, they correspond to the things that we can do inside of a linear system. All right. Then we're going to think about Gaussian elimination as a series of steps. One, we want to place a 1 in the farthest left column. We can use any of the operations in order to do that. Sometimes it'll be permutation, that is, that will switch a 1 up into it. Or we can also then sometimes divide by a number or multiply by a fraction of some sort, and that will in fact allow us to create a 1 inside of that column. Then 2, right, we will use the allowed moves to construct or to place zeros in the rows below the, and in this case it's called a leading 1, or the pivot. Then 3, use Gaussian elimination, or use the allowed move, moves, to place zeros in the rows above the leading 1. Iterate this process until there is zeros in the bottom row, or no rows of zeros. Then 2, a leading 1 in the furthest left column of each row, and zeros above and below the leading ones. Right? This form is called the reduced row echelon form. This form is the reduced row echelon form, and written as RREF of A. Okay. So we're going to think about this. First, we want to place a 1 in the furthest left column. Then we're going to use the allowed moves to place zeros in the rows below the leading one. Then we'll use the allowed move to place zeros in the rows above the leading ones. Then we're going to iterate this process. We're going to do it for every single column, right? We're going to go along each one of the columns until the zeros in the bottom row, or we have no rows of zeros. Then we have a leading row in the furthest left column of each row, and zeros above and below the leading ones. And what we'll end up with is something called the RREF of A. Okay, so let's take a look at this particular matrix here that we've set up. Okay, -3, 3, 2, -3, 5, 2, 0, -5, 1. And we set this up. It's an augmented matrix, and so it represents a system of equations. So what we're going to do is we first want to get a 1 in the furthest left column as high up as we can get. Basically, if we can get a 1 up in that corner, we want to do it. So we actually already have a 1 there. That's great. We're done with that part of the Gaussian elimination. The next thing that we're going to do, we're going to move this over, and what I want to do now is I want to get zeros. I want to make these guys into zeros. Make them into zeros. So if I think about this, I'm going to write it, and there's a couple different ways to write it. I'm going to write this one in this manner. I'm going to take row 2 minus 3 row 1. Okay, and how we write that is A 1, 2, -3. All right, so we are going to multiply row 1 by -3 and add it to row 2. All right, and so then I'm just going to write out my computation here. That's going to be 3, 2, -3, 5, and then -3 times 1, -1, -5, -3. This then gives me 0, 5, 12, 14. So my new matrix is now going to have this value in the second row. So, or that row in the second row. So it'd be 1, -1, -5, -3, then 0, 5, 12, 14. Next, I'm going to make that change that I wanted to make to row 3. So what I'm going to do is I'm going to say, okay, well, I'm going to take row 3, and I'm going to subtract 2 times row 1. And how I'll write that in notation is A 1, 3, -2. And my computation will look like this, right? This was going to be 2, 0, -5, 1. That stays the same. So that's going to be 2, 0, -5, 1, minus 2 times 1, -1, -5, -3. This will be 2 minus 2 is 0. 0 minus a negative positive, so 0 plus 2 is 2. -5 plus 10 is 5. 1 plus 6 is 7. So my new matrix has rows 1 and 2 exactly the same, but what it now has is a change to row 3. A change to row 3. The new row is row 3. Okay. Now, I'll notice that I have a leading 1 and then zeros everywhere below it. That's great. And since there's nothing above it, I don't have to worry about it being above. Now what I want to do is I want to actually get a row. I want to get a leading 1 right here, okay? In the second row, second column, if it's possible. So let's see what we can do. Basically what I'm going to do is I'm going to multiply row 2 by 1/5. And that will then give me 1, -1, -5, -3, 0, 1, 12/5, and 14/5. And then 0, 2, 5, and 7. Okay. What I now need to do is I now need to actually utilize, now need to get a 0 down here. I want to make this a 0. So what I'm going to do is I'm going to take row 3 minus 2 row 2. So row 3 is 0, 2, 5, 7. Row 2, so this is -2 times 0, 1, 12/5, and 14/5. Right? So this is still a 0. And that's one of the reasons why we start with the farthest left column, is because we'll continue to have zeros as long as we make zeros below our leading ones. 2 minus 2, that's 0. Great. 5 minus 24/5 is just 1/5, or yep, is 1/5. And then 7 minus 28/5, okay, is going to end up being 7/5. And so that's our new matrix now. 1, -1, -5, -3, 0, 1, 12/5, 14/5. Oh, excuse me. Yep. 14/5. And then 0, 0, 1/5, 7/5. And this row operation here is going to be, you add row 2 and row 3, and we're going to multiply row 2 by -2. Okay. Next up, I need to get a 0 here. That needs to be made a 0. And so what I'm going to do is I'm just going to add row 1 and row 2. Add row 1 plus row 2. And that's add, okay, 2 in row 1. And there's no scalar multiplication. So now we're going to go in, we're going to construct this. And this is going to be 0, 1, 12/5, 14/5. And then 1, -1, -5, -3. So we're just going to add those two together. This will be 1, 0. This is now 25/5, so this is going to be -13/5. And this will now be -1/5. Great. So this is now, our new matrix is 1, 0, -13/5, -1/5, 0, 1, 12/5, 14/5, and 0, 0, 1/5, 7/5. Okay, so now what I need to do is I would want, normally I'd want to get like a leading 1 right here. And I think actually that I'm going to do that. So what I'm going to do is I'm going to multiply row 3 by 5. Okay? And that'll now be 1, 0, -13/5, -1/5. Then 0, 1, 12/5, 14/5. Okay, and 0, 0, 1, and 7. Now finally, I need to get zeros above that leading 1. So how I'm going to do that is the first thing that I'm going to do is I'm going to add, I want to take row 2 minus 12 over 5 row 1. Row 3, excuse me, not row 1, but row 3. And so that is adding 3 to 2 multiplied by negative 12 over 5. So that'll be 0, 1, 12 over 5, 14 over 5. And then 0, 0, 1 and 7. Gives me 0, 1, 0, and then 14 fifths minus, and in this case, this would be 84 fifths. That gives me 60 fifths. So that's minus negative 60 fifths, so that's negative 12. And that's now our new matrix. So 1, 0, negative 13 over 5, negative 1/5. Then we have 0, 0, 0, 1, 0, negative 12, 0, 0, 1, 7. Okay. Now finally I've got to get a 0 right here. So that's just going to be my last 0. I want to get it put right there. So what I'm going to do is I'm going to add, I'm going to take row 1 plus 13 over 5 times row 3. And that is A 3, 1 times 13 fifths. Okay, so this will be 1, 0, negative 13 over 5, negative 1 over 5, and 0, 0, 1, 7. This one will be multiplied by 13 over 5. Okay, so this ends up giving me 1, 0, 0, and then negative 1/5, and then 13 over 5 times 7. It's going to be 84, 91 over 5. So this will be 90 over 5, which will be 14. Great. So that means my solution is now 1, 0, 0, 0, 1, 0, 0, 0, 1, and then down the line we'll have 14, negative 12, and 7. So that is now in reduced row echelon form. So we would say that the RREF of, in this case, what we call it is A hashtag, okay, is equal to 1, 0, 0, 14, 0, 1, 0, negative 12, 0, 0, 1, 7. Okay. Great. Now what we need to do is we actually need to figure out what this means. Well, if we rewrote it, if we expanded it out, we'd end up getting 1, 0, 0, 0, 1, 0, 0, 0, 1 times x1, x2, x3 equals 14, negative 12, 7. When I expand it out, or when I write it out, that's going to give me x1 plus 0x2 plus 0x3, right, equals 14. x2, or 0x1 plus 1x2 plus 0x3, so just x2 equals negative 12, and 0x1 plus 0x2 plus x3 equals 7. So x3 ends up equaling 7. So this form right here actually gives us the solution. What we have is, here's our x1 term, it's going to equal 14. Here's our x2 term, it ends up equaling negative 7. And here's our x3 term, it ends up equaling 7. Okay? And that's actually how we go about doing the Gaussian elimination. All right? Just to review, we're going to do a couple more examples of this. To review, what we have here is we have a process, an iterative process. We have some allowed moves. We're going to switch rows, called permutation, and we'll go permute A to B or I to J, multiply our row by a scalar, multiply that row A by the scalar S. Addition, we're going to add row 1 to row 2, or we're going to add S rows of row A to row B. Okay? In the process of Gaussian elimination, what we want to have happen is we want to get to place 1 in the furthest, a 1 in the furthest left-hand column that we possibly can, and then use allowed moves to place zeros in the rows below and above our values. Start out, you can go either way, but make sure that you start out the furthest left-hand column, get all the zeros above and below first, and then move on to the other columns. If you don't, you're just going to end up repeating work. Okay? And then iterate that process until we get to this RREF of A, which has leading ones along as much of the diagonal as possible, zeros at the bottom if there are rows of zeros, okay, and zeros above and below the leading ones. And that's your process for Gaussian elimination.